So I just want to show two more things with MATLAB slicing, and then you should be pretty well versed in accessing data stored in a matrix in MATLAB. So the first is this use of the colon operator. So let's recall what x is. X is this. Let's say I wanted to find, well, if I did this, x colon colon, then what I'm really saying is all the rows in all the columns of x, so I should just get x back again, and that's what I get. Sometimes I want to find all of the elements, but I want to stack them in a vector. So what I can do is I can do this. So now I'm saying just unpack everything and give me a vector that represents all the elements in x, but sort of flattened into one big vector. So we can see this is how MATLAB represents data. This is the first column of x, this is the second column of x, and so on and so on. So that's just some convenience that you might want to do. Sometimes you actually want to just take a matrix n by n and turn it into an n times n vector. You can do that with this, and actually you could also do x transpose, and it will just give you a 1 by n times n matrix. So that's some functionality. A second is this use of the word end. End is a keyword used in MATLAB, and you can also use the keyword end to access matrices. So end in MATLAB represents the end element of a row or a column. So if I have, let's say, x, okay, I want to find the end element of the second column, then I could write it, well, first I could write it like this. If I knew x was exactly 3 by 5, then I would know that 3 represents the last row, and so I could write 3 comma 2, and I'd get 12. Sometimes I don't know that x is 3 by 5, maybe it's n by 5, and n is a number that I don't know, and so, but I always want to access the last element. Then I could write end, and that gives me the same result, because end represents the last of whatever. So I could also write x, let's do the end element of the second row. So now I want the second row, the end element of that, which should be 10, and indeed I get 10. So this is nice because sometimes we want to find the last of something because we've got say a temperature probe. So I've created a t variable here. It's a whole bunch of temperatures, and I want to find, let's say we've organized the data so that each column represents some point in a process or a reactor, and this is, say, temperature over time. So as we move down the column, that's how the temperature changes over time. So if we wanted to find, I don't know, the current temperature at probe 4, which is column 4, then we could do t end 4, and that's something that we do. Sometimes we actually want to find the last say 10 rows or 3 rows of a big matrix. So y, let's recall y was, how big was y? 157 by 8 matrix. It's a huge matrix, and we just want to find, say, the last 3 rows. We don't know that y is 157 by 8 matrix. We just want the last 3 rows. So what we can do is we can say y, and then combine all of these tricks into one big slice. So we could say, okay, let's do the first 3 columns. So 1, 2, 3. I want to find columns 1, 2, 3. And then I want to have the last, let's say the last 3 rows. So I want to find this number, this number, this number, up to that number. Then what I could do is I could employ end. So I could say end minus 2 to end. Right, so what I'm doing here is this statement, the use of the colon represents generating a matrix of indices, and then the end represents how far must I be in that index. So I'm going end minus 2 all the way up until end, and then I'm finding all of those elements for the 3 columns. So if I do that now, I get a 3 by 3 matrix, but it's actually only this small block. It's only that small block over there. So that's some nice functionality. End is also used a lot, and it's good to know. It's a good way of finding the last element.